Hi folks, welcome to my YouTube channel Data Science with Sid. Today we will solve some PYQ questions from Jan 2023 for the subject Machine Learning Foundation. So let us start with the question number 1. So the question number 1 is which of the following are true about loss after applying encoder and decoder functions to a given data? So there are four options, and this is a MSQ question, multiple select, and we have to find out the which options are correct. So the for encoder and decoder functions, there are some formula given. Encoder, what is encoder, what is decoder, and for decoder, the dimension of the input dimension must be less than equal to input dimension of encoder. There is condition, and there is some goal behind. We have to minimize the loss, and there is a formula for loss which is given. This is important for this question, and by with the help of this formula we can easily eliminate the wrong option. So what is the first option? The first option is the loss value can be equal to any real number. So this is saying the loss can be any real number. Let us suppose the loss is minus 2.32. So with the help of formula we can say that the loss value cannot be negative because it's taking modulus square value of modulus. So the loss always be equal to positive real number, always be equal to positive real number. So the loss cannot be negative. So this is cannot be any real number. If it says that can be equal to positive real number, then it is correct. But this is saying any real number. So the in any real number there may be a possibility of negative real numbers. So this is not a correct option. So the second option is that the loss value cannot be negative. So this is true because cannot be negative. We have taken modulus. So cannot be negative. This is correct. A perfect encoder and decoder function will not exist for any data, that is, the loss value can never be equal to 0. So the for perfect encoder and decoder function, loss value cannot be equal to 0. So it is possibility of the loss can be equal to 0 because if our output value is approximately equal to input value, then the loss can be equal to 0. So this is also not correct, and for the same reason this is correct. The loss value can be equal to 0. If we achieve our goal, then the loss can be equal to 0. So the second and fourth options is correct. Okay, so hope you understand this problem. So let us start with the next problem number 2. Problem number 2 says which of the following statements are true. So the first option is email spam detection falls under classification problem. So this is correct because email spam detection typically involves classifying emails into two categories, spam or non-spam. So this is a classic example of binary classification problem. So this is true. And second is predicting the price of a house based on previous data sets falls under classification problem. So this is not correct, as you know that the predicting the price of a house based on previous data sets is a regression problem, not a classification problem. Regression involves predicting a continuous value such as a house prices, and while classification involves predicting a categorical value. So this is not correct. So for third option, classifying whether handwriting belongs to a particular person or not based on previous data falls under classification problem. So this is true because handwriting classification is a example of classification problem, as it involves categorizing handwriting samples into different classes, such as identifying whether they belong to a particular person or not. So this is an example of classification problem. So this is true. And fourth is find out the probability that a particular poem is written by Shakespeare falls under unsupervised learning. So this is this question, this options asks about probability that a particular poem is written by Shakespeare or not. Shakespeare. So in this is a probabilistic models. So and probabilistic models falls under unsupervised learning, as you seen. And if we have to find what is the probability that a given tweet was generated by Mr. Chopra, then it is probabilistic model, because we need to assign a um, for this problem we need to assign a problem score to every poem and given high scores to those that are likely to be from original source. So this is a probabilistic model and this falls under unsupervised learning. So this is also the fourth option is also true. So the fourth option is also true. If you talk about probability, then this falls under probabilistic models, and probabilistic models comes under unsupervised learning. Okay. So let us start with the next problem. Problem number 3. Which of the following statements are true about function? And there is function given, and we have to find out which statements are true. So to solve this problem, first we have draw a graph. Draw a graph of mod x, and for as you know that for function to be continuous, LHL should be equal to RHL, and that will be equal to value of the function at that point. And you have to find out the value of right RHL and LHL at x equal to 0. Okay, so the at x is equal to 0, if you talk about at x is equal to 0, so the at x is equal to 0, the right hand limit is this 1 by x, that will equal to infinity, and left hand limit is also equal to infinity, and but the value of the function at that point is equal to 0, because at x equal to 0, if we talk exactly about x equal to 0, the value of the function is given as 0. And for the same reason, since RHL equal to LHL but does not equal to value of the function at 0, so the function is not continuous at x equal to 0. And because function is not continuous, then function is also not differentiable at x equal to 0, because for function to be differentiable, it must continuous. So because function is not continuous, then it also not differentiable at x equal to 0. So you can easily eliminate the wrong option. So second option says the function is differentiable for all values of x. This is not correct, because function is not differentiable at x equal to 0, and the function is continuous at x equal to 0. This is also not true, because we have seen that the value of the function is not satisfying the right hand limit or left hand limit, so the function is also not continuous at x equal to 0. So the first and fourth are correct. Okay. So let us proceed with the next problem. Problem number 4. Which of the following statements are true? So there exists a n cross n matrix A, where n is odd, for which the rank of A is not equal to nullity of A. Okay, there exists, suppose there exists a n cross n matrix, let's suppose 3 cross 3 matrix. So the from rank nullity theorem, rank of A plus nullity of A is equal to 3. Since their sum is odd, their sum is odd, so rank of A plus nullity of A is equal to 3. So the rank of A cannot be equal to nullity of A, because n is odd, 3. So the rank of A is not equal to nullity of A. This is correct. It is not possible that the rank of A equal to nullity of A. Okay, and for the same reason, the second option is incorrect, because this saying rank of A is equal to nullity of A, because it is not possible. So second option is incorrect. So let us see the third option. There exists a n cross n matrix A, where n is even, for which the rank of A is not equal to nullity of A. So the for, let us suppose there is a 4 cross 4 matrix. Okay, and from the rank nullity theorem, we know that the rank of A plus nullity of A equal to 4. So the let's suppose the rank of matrix A is equal to 0, then the nullity must be 4. So the rank of A does not equal to nullity of A is possible. In case of rank is equal to 0 and nullity is equal to 4, so the not equal to nullity of it is possible. Okay. And fourth option says there exists n cross n matrix where n is given for which the rank of A is equal to nullity of A. So this is also possible. If we take rank is equal to 2, then nullity is equal to 2, and this implies the rank of A is equal to nullity of A. So this is also possible. So the fourth option is also possible. Okay. Hope you understand this problem. Let us proceed with the next problem. Problem number 5. It says let P be the matrix that projects vectors in R3 onto the subspace spanned by the vector A. Which of the following are eigenvectors of P corresponding to the eigenvalue 0? Which of the following are eigenvectors of P? So first we have to find out what is P. Okay. Then we will talk about the eigenvectors of corresponding to eigenvalue 0. So for matrix P, what is the property of matrix P hold? So the P be the matrix that projects, it's actually a projection matrix. If we take some vector B and we have to project this vector on this vector spanned by the vector A, let's suppose this vector A, if we have to project this vector B, we have to draw perpendicular line from this vector onto this vector, onto this subspace spanned by this vector A. So and this will be this projected projection will be equal to x cap times of A, and x is some transformation matrix. Okay. And that transformation matrix is called as projection. Okay. And this formula is for projection matrix is A transpose upon A transpose A. This is projection matrix. If we have to project this vector onto this subspace, we have to multiply this by A, where we have to project P times A. Okay. So this is projection matrix. So P is our projection matrix, where formula for projection matrix is A transpose upon ATA. As you can see, professor has proved this formula. Okay. And second, what is this? We understand that what is P. Now read this line. Which of the following are eigenvectors of P corresponding to eigenvalue 0? So for eigenvectors of P, where P is a projection matrix corresponding to the lambda is equal to 0, because we know that from property of eigenvector, P minus lambda I of x is equal to 0. Because lambda is 0, this is 0, so the Px is equal to 0. This Px is equal to 0. So Px is a null space. So we have to find the null space of this vector P. Okay. So our projection matrix is this. So we have substituted the A transpose upon this, and this can be also written as modulus of this squared of mod of A, and we have written. And we don't need to solve for projection matrix A transpose upon A transpose A. This is a lengthy process. You can solve this way also by finding the projection matrix, but I have solved using this method, because A upon mod A square, because A is non-zero matrix, so we can easily say that A does not equal to 0, and so because this is non-zero, we can say that A transpose x must be equal to 0. So we will check dot product of vector A transpose and eigenvectors. So eigenvectors are given. Which are the following eigenvectors? So these are the eigenvectors. These four options are eigenvectors. We will check if eigenvector satisfying this property, then those options are correct. So the first So for the first option, we taken A transpose 1 minus 2 with 1 2 3. This is equal to 1 minus 4 plus 6, 7 minus 4, which is 3, does not equal to 0, does not equal to 0. So this is not a correct option. Okay, so this is not correct option. Similarly, if we take dot product with 2 minus 1, this is not equal to 0, so this is also not correct. B option is also not correct. If we for C option there is 0, and for fourth option also 0. So the eigenvectors corresponding to eigenvalue 0 for projection matrix P, these are correct, because these two vectors satisfying this holds this equation A transpose X is equal to 0. So hope you understand this problem. This is a very tricky problem, you can easily find out, but you can proceed with this lengthy process by finding projection matrix A transpose upon A transpose A, and then you can multiply with 0 x, and then you can solve this vector x. This is a very lengthy process, but we don't follow this method, and we have follow this smart way to find out the correct options. Okay, so let us proceed with the next problem. Question number 6. This is a higher order approximation problem. This is a quadratic approximation of the function. There is a function given at x equal to pi by 4. We have to find out the approximation of this function, a quadratic approximation. Okay, so to solve this problem, we will use this formula. This is a formula used by Professor for quadratic approximation. So we will find out there is a function x square at x equal to pi by 4. So we have calculated the value of function at pi by 4, which is equal to 1 by 2. Then we take derivative of that function, which is equal to sine 2x, and we will calculate the first derivative at pi by 4, which is equal to 1. Then because in the formula there is second derivative also, then we will take second derivative of this function, which is equal to 2 cos 2x, and we calculated the value of second derivative at pi by 4, which is equal to 0. And then we substitute all required values of into this formula. So the value of the function at x equal to pi by 4 is equal to 1 by 2, and this will be 0, because second derivative at pi by 4 is 0, so this term will be 0, and we have substituted the value and get the result 1 by 2 plus x minus pi by 4, which is second option. So the second option is correct. Okay, thank you. We will solve the remaining problem in the next session. Okay, thank you.